Hello everyone, in this video I'm going to be talking about the inverse of a function. A function has an inverse if the function is one-to-one. What that means is that one input has only one output. It cannot have two outputs. Graphically, the easiest way to determine if a function has an inverse is by doing the horizontal line test. And let's do two examples. The horizontal line test is similar to the vertical line test. All we're going to do is create a line going through the function horizontally in this first example. And here we can see that the function crosses this horizontal line at 2 points. This means that this fails the horizontal line test. So this function has no inverse. If we look at the next example on the right, we can try to draw a different horizontal line test. Let's see, at different points of this line, there's actually no point where the function has more than one output. It passes the horizontal line test because the horizontal lines touch the function at only 1 point. So this one actually has an inverse. When you think of inverse actually means opposite. So what the inverse function does is that it undoes the operations of the function, of the original function, and reverts them back to its original. So originally, we have an input x, and what the original function does is that it takes your x into your y. But what the inverse function does is that it takes y and it turns it back to x. So in reality, now your y is your input and your x is your output. So our x and y's get switched. Finding the inverse of a function usually follows the same steps. We can first rewrite our function f of x equal to y, and then since our inputs and outputs flip, we can switch the x and the y's, and then just solve for y normally. Our final step would just be to rewrite our new y as the inverse of a function, which is denoted by f to the power of -1 of x. So let's do some examples. In the first example, we have f of x is equal to 2x minus 7. And remember that our first step is to rewrite the function f in terms of y. So we would have y equal to 2x minus 7. So now we can switch x and y. If we do that, we would get x is equal to 2y minus 7. And we can solve for what our new y will be. So by doing this, we're actually undoing all the operations that the original function had. So we would be left with x plus 7 is equal to 2y. And to get rid of the 2, we can divide both sides by 2. So our y is equal to x plus 7 over 2. So this is what our inverse function is. And to just denote that this is an inverse function, we would have to write f to the -1 power of x is equal to x plus 7 over 2. So this is our inverse function. And one way to check if we did all our steps correctly is to plug this function into the original function. What our result should be is x, because that means that we are undoing all the steps that we originally did. So let's try and check our work. Our original f of x was 2 times x. Remember that now we're going to take our inverse function and plug it in. So we're going to take the inverse function, which is x plus 7 over 2, and plug that into our function. And then it's being subtracted by 7. Let's try to simplify this and see if we get x. Here we have a 2 divided by a 2. That can cancel out. And this would be x plus 7 minus 7. 7 minus 7. That is 0, so all we have left is x. Yay, we got it. Okay, so this is in fact our inverse function. Now let's try another one. Our function this time, g of x, is the square root of x plus 2. So we're going to do the exact same thing. Our first step is going to be to change g of x into y, and then we would have to switch our x's and our y's. So if we switch them, we would be left with x equal to the square root of y plus 2. And now let's just solve for y. Since we have a square root, one way to get rid of it would be to square both sides. So if we square both sides, remember that the square root cancels out the square. So we're left with x squared equal to y, now it's outside, plus 2. And we can subtract 2 to both sides to get y by itself. Now we have y is equal to x squared minus 2. All right. Our final step is just to rewrite y back into the f inverse notation, and this would just be our final answer. To check, remember that all we have to do is take our function and plug it into the original function. So the original function was the square root of x. Instead of writing x, we're going to write x squared minus 2. And inside, we have a plus 2 right next to it. If we simplify this, the 2's get canceled out, so we're left with x squared. And again, a square root and a square, that gets canceled out, so we are left with x. So this is our inverse function. Now let's try to find the inverse of the function h of x, which is equal to x plus 1 over x plus 2. So here we're going to perform the exact same steps. We're going to change h of x into y, and then we also have to switch our x's and y's. So we're going to switch them so we would have that x is equal to y plus 1 over y plus 2. This time it's a little different because now we have two y's in this case, but something we can do is rewrite x over 1 and cross multiply. Cross multiplying will get the y in the denominator out of the way. So let's try to do that. We can multiply x times y plus 2, and that's going to be equal to y plus 1. We have to solve for y. And there's actually a y inside parentheses, so that means we have to distribute our x. So we can distribute x times y plus 2x equal to y plus 1. And now the next step would be to isolate all the y's onto one side of the equation. So what we can do is subtract 2x to both sides, and then we have xy is equal to y plus 1 minus 2x. And to get all the y's onto one side, we have to move over this single y. So we have to subtract y to both sides, and we have that xy minus y is equal to 1 minus 2x. Okay, we're getting closer. Since both terms on the left-hand side have a y, what we can do is factor out a y. So we have, on the inside, we're left with x minus 1, because we factored out 1y, equal to 1 minus 2x. Okay, now we are so close. All we have to do now is divide by x minus 1 to both sides to get rid of the x minus 1 and leave y completely by itself. So the y that we get is y is equal to 1 minus 2x all over x minus 1. And the final step would be just to rewrite y in inverse notation. So this would be the inverse function find. But we still have to check, just in case that we... So to check, remember that we're going to just take our original function, and wherever we see an x, we're going to replace that with our inverse function. So here we have a complex fraction. And remember that in a previous video, I told you guys that one way of simplifying a complex fraction is to multiply everything by the LCD over 1. The LCD in this case is x minus 1, because if we look at all the denominators, x minus 1 is the only denominator, because the denominator of 1 is 1, and the denominator of 2 is also 1. So we're going to take x minus 1 over 1 and multiply to every single term in this complex fraction. If we look at this term, we can see that the x minus 1's cancel out, so we're left with 1 minus 2x. And in the second term, we don't actually have anything canceling out. So 1 times x minus 1 is plus x minus 1 all over. And here in this bottom denominator, we have x minus 1 canceling x minus 1 out. So we have 1 minus 2x. And in the second portion, we have 2 times x minus 1. So we have plus 2 times x minus 1. And now let's just simplify this a little bit down. We can cancel out our 1's. 1 minus 1 is 0. That goes away. So we're going to be left with negative 2x plus x all over 1 minus 2x plus, we can distribute this 2. So we're going to have 2x minus 2. All right, let's see what we get. The 2x's cancel out. So we are left with negative 2x plus x, that is negative x, all over 1 minus 2. 1 minus 2 is negative 1. So we have negative x divided by negative 1. A negative over a negative, that is a positive, so we have x over 1 or just x. So we did get our result back. So this is our official inverse function. So this is generally how you can always find the inverse function of any type of function.